So, let us have some interactive problem solving sessions by students who have taken this course. So, you will see some illustrations and examples into problem solving which is useful to understand and digest the concepts learnt during the lectures.
Hello all, I am Amrita, a PhD student at IISc. I will be showing you a demo on implementation of KL transform. First, let us look at the code for implementing KL transform. Let us consider 5 input images. So, here I have 5 images and each image is of size 64 by 64. For KL transform, we have studied that the input to the transform should be in the form of a row vector. For this purpose, we convert our images into a row vector of size 1 by 4096. The first step in KL transform is to create the data matrix D. So, in the data matrix D, we have each row corresponding to one of the input image. So, the dimension of the data matrix D will be 5 by 4096. That is performed here. The second step is to compute mu D, that is the mean vector along each of the dimension present in D. So, mu D is a row vector of dimension 1 by 4096. The next step we perform here is to make the data matrix 0 mean. For this purpose, we create matrix B, where we subtract the data matrix and the mean that we computed mu D. So, the data matrix B now has 0 mean. The next step is to compute the covariance matrix C, which is given by B transpose B, that is actually nothing but D minus mu D transpose D minus mu D. So, we compute the covariance matrix in this step. Once the covariance matrix is computed, we use the eigenvalue decomposition to extract the eigenvalues and eigenvectors of the covariance matrix. So, here we obtain V, which is a square matrix of size 4096 by 4096, where each column corresponds to one eigenvector of the matrix C. Similarly, we get sigma matrix, which is a diagonal matrix, where we have the eigenvalues along the diagonal elements. So, once we obtain the eigenvalues and eigenvectors, we extract the eigenvalues from the diagonal elements and store them in eigenvalues. For KL transform, we need to sort the eigenvalues in the descending order. So, once this is performed, we rearrange the eigenvectors based on the order obtained. So, let us see how the eigenvalues are obtained after making them in the descending order. Here along the x axis we have all the eigenvalues, and along the y axis we have their corresponding amplitude. We see that most of the eigenvalues are close to the range of 0, and there are a few values that have a value much greater than 0. So, for this purpose, let me zoom into the initial location and see how many eigenvalues have value much greater than 0. We see that we get 1, 2, 3 and 4 eigenvalues which have amplitude or value much higher than 0. So, using this information, let us see if we can reconstruct the images. So, here we choose K, that is we choose the first K dominant components for the reconstruction part. So, based on the value of K, we choose K eigenvectors corresponding to the K dominant eigenvalues and use those eigenvectors for reconstructing the images. So, let us use a MATLAB GUI to see how this performs. So, these are the set of 5 images that I have used for the KL transform. Let us choose k equal to 1 and see what happens. So, when I perform KL transform, these are the images that I get after reconstruction. Visually, we can see that the images are not as expected, they are not close to the original images. Let us increase the value of k and see if there is any improvement. We see that the 5th image is corresponding to the original image visually, but the other images are still not close to the original ones. So, let us try increasing the value again. We see that almost all the images are close to the original images except a few. So, the last try we see is by taking k equal to 4. Now, we see that all the images 1, 2, 3, 4 and 5 are close to the original images. This is because we saw that only 4 eigenvalues are having value much greater than 0, that is they are the dominant eigenvalues for these 5 images. So, let us see what happens if we increase the value of k beyond 4. Let me use say 40. We see that even after taking 40 dominant eigenvalues and vectors into consideration, there is not much difference in the reconstructed images that we obtain. So, this shows that by using only the dominant k eigenvalues, we will be able to reconstruct the images. Thank you.